We have an example problem here. Non-reflective coatings for camera lenses reduce the loss of light at various surfaces of multi-lens systems, as well as preventing internal reflections that might mar the image. Find the minimum thickness of a layer of magnesium fluoride on flint glass that will cause destructive interference of reflected light of wavelength 550 nanometers, which is near the middle of the visual spectrum. So this would be an example of optical coatings, which is still thin film interference. If you have a really nice camera and you look at the lens from the outside, from the side that you would be taking the picture of, if you move it around and hold it at different angles, you can likely see different colors. So here, we're trying to find the minimum thickness of a layer of magnesium fluoride on flint glass. So our thin film is this magnesium fluoride, which they've told us has an index of refraction of 1.38. It's on the glass, the flint glass, which has an index of refraction of 1.66. Up here would just be air, because somewhere over here is what we would be taking a picture of. So in this particular situation, n of the surface is greater than n of the film. So that means we want one of the equations that is in the column labeled n of the surface being greater than n of the film. We still have to decide whether we want the constructive or destructive equation. Well, that one is hopefully fairly straightforward because it is asking us specifically the minimum thickness that's going to cause destructive interference. So let me grab the lambda sub d, the wavelengths that will destructively interfere. So if n of the surface is greater than n of the film, lambda sub d is 2nd over m minus 1/2, where m is 1, 2, 3, 4, so forth. We're trying to find the minimum thickness, so we're trying to find d. So if I bring everything over to the other side, d is going to be smallest when m is smallest. So minimum thickness is going to be when m is 1 specifically, because if we use 2, we'll get a bigger value of d. So they've asked us to find the minimum thickness to cause destructive interference for light of wavelength 550 nanometers. And then n is always the index of refraction of the film. So 1.38 is our film in this case. So I'm getting 99.6. My units are in nanometers because the units of my wavelength are in nanometers. So a very thin coating, and it will minimize this reflection.